In this goal, we are going to be balancing the equation for any given redox reaction. The rules for balancing the redox reaction should have been given to you in some printed materials for you to use as a reference. But the first thing you want to do is assign oxidation numbers and then identify the atoms that are being oxidized and reduced and draw those arrows to connect them. Then you're going to balance those that you've connected. So you're going to be concentrating on the ones that are just oxidized and reduced. You want to make sure you have equal amounts on each side. And then you want to balance the electron exchange. So if you're losing 2 electrons, you want to be able to gain 2 electrons. You want to make sure those numbers are the same. You also want to balance for the rest of the atoms that are there in that equation. And then last but not least, double check everything, because when you're balancing these, you need to balance them for atom and also charge. So again, balance them for the number of atoms, the number of electrons exchanged, and also the charge on either side of the equation. So let's go ahead and do an example here. So my examples are going to start out simpler and then get more complex. With the simpler ones, we want to use these to follow the steps and the rules of how you're going to balance for that electron exchange. So the ones on this page you might even be able to do in your head and figure out what they are, balancing for atom and charge. But let's go through the steps. So first of all, assign oxidation numbers. So this one's a +1. This is an element, so it's a 0. This is an element, so it's a 0. And this is a +2. So this is a net ionic equation. So all the spectator ions are taken out. So that's why I have charges on either side. And you can see on the left-hand side, I have a +1 charge. And on the right-hand side, I have a +2 charge. And so it does have to be the same. So this really is not balanced. So after we assign the oxidation numbers, we're going to connect the ones that are changing. Then we're going to figure out, is it losing or gaining electrons, and how many? So my silver is going to go from a +1 to a 0. It's going to be gaining. My number goes down. And it's specifically going to be gaining 1 electron. So that means this copper must be losing electrons. And I see that it's going to lose 2 electrons. So you cannot gain 1 electron and lose 2 electrons. You need to have them match. So I'm going to multiply this 1 by 2. Now watch this step. You're going to follow the arrows and put a 2 in front of each one that is connected. So this will give me a net gain of 2 electrons, which is what will balance this equation. So gaining 2 and losing 2. All right, so this one should be balanced. So it's balanced for atom. I have 2 silvers on either side, and then I have 1 copper on either side. And then my charge, on this side, I have a total charge of +2. And on this side, I have a total charge of +2. So everything's matchy-matchy. I have equal amounts of atoms, equal amounts of electrons that are gained and lost, and equal amounts of charges on either side. All right, let's go ahead and do this next one. Why don't you stop the video and see if you can do it by yourself, just looking at the steps that I've gone through. And then we'll come back and do the answers. Okay, we're back. So first assign oxidation numbers. Aluminum is a 0. Copper is a +2. We have this aluminum ion is a +3, and my copper atom is a 0. We are going to connect the ones that change. And then identify how many electrons are gained and lost in each case. So I am losing 3 electrons here. Remember, electrons are negative. So if my number goes up, then electrons have been lost. If my number goes down, then electrons are gained. That's the reducing part. So I am losing 3 and gaining 2. So this does not match, so I need to fix it. So a number that 3 and 2 go into are 6. So I'm going to multiply this one by 2, and then I'm going to put a 2 in front. That's multiplying everything by 2. So each one of these aluminums is going to lose 3 electrons for a total of 6. And then the ones that are gained, I'm going to multiply this one by 3 and then follow my lines. That's where my 3's go. So this means that each one of these copper atoms is going to gain 2 electrons for a total of 6 electrons gained. So I have 2 aluminums on each side, 3 coppers on each side, so that matches. And then I have matched my 6 electrons lost and my 6 electrons gained. And last but not least, look and see the total charge on either side. I have a total charge of a +6 here. That's because we've taken away the spectator ions. And so we're just looking at those cations. All right, so everything matches, so this is balanced. All right, let's try one that's a little bit more difficult that you probably won't be able to do in your head to balance it. So you'll need to be able to follow these steps. And I do have problems like we just did previously that you can kind of sort of do them in your head. I'll have some of those on the test, but I'm also going to have some of these more difficult ones on the test. So you need to know how to do this. There are also more difficult ones like this in your homework. So again, go through, follow the steps, the rules for assigning those oxidation numbers. So quickly, I'm going to assign my oxidation numbers. Oxygen's a -2. I have 7 of them for a total of -14. That means my chromiums, well, it has to all equal a -2. So that means my chromiums have to be a +12. So each one of them is a +6. All right. Then they basically tell me what the charges are on these that are all by themselves. So I love it when they do my work for me. And last we have water. So hydrogen's a +1, oxygen's a -2. And again, we do see that with math that everything will be neutral. So again, your ions combine with their oxidation numbers to form neutral compounds. All right, I want to get rid of my math because it's just in the way. And these are the oxidation numbers of one of each of these elements. All right, so once we assign the oxidation numbers, I'm going to connect what is changing. So I have chromium changing, and then I have tin changing. So the ones that are connected, you need to make sure that those are balanced. So looking at my chromium, I have 2 chromiums there. So right off the bat, I need to put a 2 in front of that chromium on the right-hand side. And then my tins look okay. I have 1 and 1, so I'm good. So let's figure out which one is losing, which one's gaining, and how much. Let's start with the chromium. So our chromium, we're going from a +6 to a +3. And so I am gaining 3 electrons. Remember, electrons are negative, so when they're gained, the number goes down. So this is 3 electrons each. So watch out for this. So notice I have 2 chromiums over there. So I have a total gaining of 6 electrons. Let's look over at the tin. So we have, going from a 2 to a 4, we are losing 2 electrons. And I only have 1 there, so I'm just losing a total of 2 electrons. Well, I can't gain 6 electrons and lose 2. They need to match. So I'm going to multiply this one by 3. And when I do that, I'm going to get 6 electrons. So take that 3 and follow your arrows, and I'm going to put a 3 in front here and a 3 in front here. All right, so now I've balanced my electrons. I'm gaining 6 and I'm losing 6. And I balance the ones that are oxidized and reduced. The next thing is just to balance the leftovers. So I have a water on the right-hand side and also have a hydrogen on all by itself on the left-hand side. So I need to balance my oxygens. So let's look and see what my oxygens are doing. So I have 7 oxygens right there. So I'm going to put a 7 here on the right-hand side. That's going to give me 7 oxygens. And that is going to change my hydrogens. So I'm going to have 7 times 2, 14 hydrogens. So over here, I'm going to put a 14, which is a little crazy, but that's how these redox reactions are. So I think this is balanced. I just need to go through and double check that everything is the same. So I know my electrons are still balanced, but let me just total up atoms. So I have 2 chromiums on this side, and I have 2 chromiums on this side, 3 tins here, 3 tins here. I'm going to have 7 oxygens here, and over here I have my 7 oxygens, 14 hydrogens here, and I have 7 times 2, 14 hydrogens here. So I also need to double check that I have my charge on each side match. So my charge here and my charge here, they should match. So on this left-hand side, I have a plus 14, and I have a plus 6, and I have a minus 2. For a total charge of a plus 18. And over here I have a plus 6 and a plus 12. And when I add those up, I get my plus 18. So positive 18 on either side. And so the reason the number is so big, remember I have spectator ions there that are going to be anions, negative ions. So it's not like I'm going to have a really charged beaker solution. It has spectators in there. We've just gotten rid of them for these redox reactions. Okay, I'll do one more example if you need it. Again, sign oxidation numbers, so 0 here. This one's a plus 1. A minus 2, I have 3 of them for a minus 6. I have a plus 1, so that means this is a plus 5. This is a plus 1. This is a minus 1. All right, I'm going to get rid of my math. And then I'm going to connect the ones that change. So I have my iodine is changed, and the other one that's changed is the chlorine. All right, so the ones that you connected, you want to make sure those are balanced. And so I have 2 over here, and now I have 2 over there. And my chlorines are already balanced, so I don't have to do anything there. There's just 1 and 1. So let's figure out what is being gained and what is being lost. So with my iodines, I am losing 5 electrons. I'm going from a 0 to a plus 5, but each. So this is a total of 10 electrons. So watch out for if you have any doubles there. And let's look at my chlorines. They should be gaining, because if you're losing 1, then the other one has to be gaining. So, and I'm going to gain 2 electrons. All right, so I'm losing 10 and gaining 2. So I'm going to have to multiply this one by 5. So I'm going to take that 5 and I'm going to put it in front. Put it in front of the whole thing. And so now I am gaining 10 electrons. So losing 10 and gaining 10. So your next step is just to balance anything else. So any other one that's not participating in the oxidation reduction. So let's start off with our oxygens, because looks like I only have oxygen once here. So I have 6 oxygens on this side, and this side I have 5 and a 1. Oh, so I'm good. I have 6 oxygen on that side, so that's good. I don't have to do anything there. Let's look at our hydrogens next. So our hydrogens, over here I have 2 hydrogens, and I'm just going to leave that one alone for right now. So, and then over here I have 2 hydrogens plus 5. So I have 7 hydrogens here. And over here I already have 2 hydrogens, so I'm going to just put a 5 right there. So I should have 5 hydrogens on each side. So oxygens and hydrogens are balanced, and there's nothing else there. So let's go ahead and just make sure everything is balanced as it should. So electrons are balanced. Our elements that are being oxidized and reduced are balanced. So let's just kind of go through and count. So I have 2 iodines here and 2 here. I have 5, 6, 7 hydrogens here, and over here I have 7 hydrogens. I have 5 plus 1, 6 oxygens here, and I have 6 oxygens here. And my chlorines, I have 5 chlorines here, and over here I have 5 chlorines. So this is balanced. We can also balance the total charge on either side just to kind of make sure, but it should be balanced. So I have on either side, on this side I have a charge of 0, so I better have a charge of 0 on this side. Oh, and I do. I have a plus 5 and I have a minus 5. So those cancel out. So they are neutral and everything's matchy-matchy, so it is all balanced.